Hi, everyone. I'm back again. We're going to talk about inequalities. Now, your comfort level with inequalities could be really varied, and that's totally okay. We're going to be working on this. So, what I want you to do, is there are two questions. Here's the question. What do you remember about graphing inequalities, such as number 4 and number 5 below? And then what is a test point and how can it help us? So what I want you to do is I want you to pause the video right now. I want you to take a few minutes or however long it takes to jot down everything you know, even if you're like, gosh, I'm not sure if this is true. I'm not sure. All of that's okay. And then do your best to think about what a test point is or could be. You can pause the video right now, and when you're ready, you can start it up again. Okay, I'm going to assume you paused, and I'm going to assume you're starting it up again. So inequalities. I'm going to write number 4 up here. Y is less than or equal to negative 2x plus 4. And so what makes this an inequality and a linear inequality is this is still in the y equals mx plus b form. The only difference is this sign right here. And this is a less than or equal to. So if I take a look at a number or at an inequality like y is less than or equal to 8. A possible number for y could be 3, because that's less than 8. 4 could be 4.2. It could also be 8, because this number has to be less than or equal to 8. Okay, and so 8 is not less than 8, but it is equal to 8. So when we think of these numbers, when we're graphing, we have to remember a couple of things. So when we have a less than or equal to or a greater than or equal to, we're going to use a solid line. When we have a less than or greater than, we're going to use a dotted line when we graph those. Okay, and we're going to use a test point for shading. Okay, and remember in class, our last 2 remote or in-person days, you remember that for the bake sale problem, we had some problems that were shaded. Okay, so now I'm going to push this up, and here goes number 4. Okay, so what I get to do first is I actually get to ignore the inequality for a second. Y equals negative 2x plus 4. Okay, so my m is negative 2 over 1, and my b is 4. Cool, I can do that. So I'm going to go up to 4, put a dot, and then I'm going to use my slope, change in y over change in x, and I'm going to go down 2 over 1. Down 2 over 1, down 2 over 1. Okay, and then I'm going to go up 2 over 1, up 2. Okay, now here is where we have to use the inequality. So a less than or equal to sign is going to tell us that that needs to be solid line. That means that it could be anything in the shaded region or on a line. So I'm going to connect this. Should be using a straight edge. I'm sorry. My squeaky table. Okay, but where do I shade? Now here's where a test point comes in. So basically you pick any point you want. The best one, if you can use it, is 0, 0. So what that means is x equals 0 and y equals 0. And so what I'm going to do is I'm going to plug 0 and 0 into my original equation. 0 is less than or equal to negative 2 times 0 plus 4. And then I'm going to simplify both sides. So 0 is over there. Negative 2 times 0, 0 plus 4 is 4. Is that a true statement? Is 0 less than or equal to 4? The answer is yes. If the answer is yes, that means wherever my test point was, I'm going to make sure that side is shaded. If the answer was no, I would have shaded up here. Okay, let's try another one. So this one's also in y equals mx plus b form. Okay, so my slope is 1 over 3, and my y-intercept is negative 7. So I'm going to go down to negative 7, and then I'm going to go up 1 over 3, up 1 over 3. Okay, well that looks kind of weird. It's hardly on the graph. Oh well. Now I'm going to look at my graph line, or my inequality. That's going to be a dotted line. So that means it's everything that's greater than the equation, but not including the line. Oops. Oh, shoot. Okay. Pretend. I'm sorry, guys. Pretend that is dotted. Okay. Now I have to use my test point to see where I shade. So I'm going to use 0, 0 again. And I get 0 is greater than 1/3 times 0 minus 7. So I plugged 0 in for y and 0 in for x. So when I simplify that, I get 0 is greater than -7. Is that a true statement? Yeah, 0 is greater than -7. So that means wherever this is, that's the side that I shade. If the answer was no, I would have shaded down here.